So we are doing the first half of factoring today. So we are going to factor greatest common factor, grouping, and then we're also going to do trinomials. On Friday, we will add in some like special rules. So like difference of squares, we should all already know. But then it's like difference of cubes and like sum of cubes. Sarah, will you come grab this? Sorry, I didn't see your backpack there. Okay, so first two on here are greatest common factor. So for greatest common factor problems, what I think about it is as undistributing. So we figure out what we can undistribute out of the problem. So what can we divide 18 and 27 both by? 9. And then x cubed and x squared. X cubed means x times x times x. X squared means x times x. I always think about it as you can take however many the poorest guy has. So the poorest guy is the x squared, so you can only take 2. Not that we measure our wealth in exponents, but go off. Okay, and then we divide that out. So 18 divided by 9 is 2. X cubed, take out the x squared, so 3 minus 2 is just 1. So we've got 2x there. And then 27 divided by 9 is 3. And then we completely factor out that x squared. So we just close our parentheses. If you have a phone out, you should put it away. I don't want to have to be like nitpicky about phones, but like put your phones away. All right. Any questions about that first one? Okay, the second one's a little bit weird because it's under the greatest common factor category, but it's already slightly factored. So in this one, we have x squared times x plus 3. That's our first term. And then we have 5 times x plus 3. That's our second term. So for this one, our greatest common factor is this x plus 3 and this x plus 3 because we can pull that out of both of them. So we're going to pull that out front. And then that leaves behind this x squared and this 5, which will stay together, and we've got to put parentheses around them. Okay, so that is on there. Well, I mean, it was in the textbook, but I was like, this is useful as a perfect segue to how factoring by grouping works. So factoring by grouping we do when we have 4 terms. If we have 4 terms, sometimes we can factor a greatest common factor out. We'll do that some on Friday. Today, I don't think there's any greatest common factors of 4 terms. But if you've got 4 terms, the first thing you do is pull out your greatest common factor. But then usually, there's not much more you can do because there's 4 terms and like having the same thing to factor out of 4 whole things is a lot. But sometimes there's something you can factor out of just 2 of them. So here are the steps, and I left these blank boxes over here to write down the steps. Here are the steps of factoring or greatest common factoring by grouping. So you are going to factor the GCF out of the first 2. Deciding what to write. First 2. You're going to factor the GCF out of the first 2 terms. So in this case, x cubed and 4x squared. I can't pull any numbers out because I can't divide x cubed by anything, but I can pull out an x squared. So I've got x squared. That'll leave behind just an x and just a 4. So GCF out of my first 2 terms. Then I can pull the GCF out of my last 2 terms. So out of 3x and 12, I can divide those both by 3. 3x divided by 3 is x. 12 divided by 3 is 4. And then here is the magic. What's left behind in those parentheses, if grouping is going to work and if you've done things correctly. So sometimes grouping doesn't work, in which case you would then need to do something other than grouping, or maybe your polynomial is prime, meaning you can't factor it. But if grouping is going to work, then what's inside those parentheses should match. So x plus 4 and x plus 4 match. So we pull that out as our greatest common factor in the front. And then the other factor is this x squared and this 3. I can't make my box big enough. X squared plus 3 is what that says. So GCF out of the first two, GCF out of the last two, and then your answer is, I call it matchy, the matching one, and then GCF plus GCF. It's your two GCFs that you pulled out. That's what your two answer is. So x plus 4 was the matching one. GCF plus GCF was the other one. Okay. Do you guys remember how to factor by grouping? Do you remember that it's a thing? Okay. Any questions on GCFs or grouping? They're like super closely related. Okay, we're going to move on to trinomials. So we're talking about trinomials today, and then we'll do all of our like special weird things, and then ones where you have to like factor and then factor again and then factor again. We'll do those all on Friday. So we're going to look at these top 4 first. So factor the following trinomials. If a trinomial has a leading coefficient of 1, so meaning there is a 1 in front of the x squared, or in this case, there's no number in front of the x squared because 1x squared means x squared. So if my leading coefficient is 1, so I'm going to say if leading coefficient, but I'm going to abbreviate it, is 1, this is what I need to do. I need to find 2 numbers that multiply together to be my last. Actually, instead of saying last, I'm going to say multiply together to be c, and ax squared plus bx plus c. I'm going to say multiply to c, add to b. So, factoring a trinomial with a leading coefficient of 1 is literally just a puzzle, and you have 2 hits, and you have to figure out the one set of numbers that answers your 2 hits. So in this first one here, x squared plus 6x plus 8, you have to find 2 numbers that multiply to 8 and add to 6. If you guys remember taking your like 8 and like writing, 1 and 8, 2 and 4. Which ones does add to 6? 2 and 4. So my answer is just x plus 2 times x plus 4. I can also write x plus 4 times x plus 2. I always write my smaller number first, but that's just the way I do it.
Is that like the x method?
Yes. If you like the magic x, you put your c up top. I think you put your you multiply to c, add to b. So you do like the, so this is just like a way to like visualize it in your head. So find 2 numbers, multiply to c, add to b, and then you like would fill this and this in. So you put 2 and 4, and then that's how you would get your answers. Yes. I've never been a personal fan of the magic x, but like people do be liking it. And Mr. Garrett likes it a lot, I think. Mm-hmm. Mr. Garrett coerced me into teaching my Algebra 1 kids it too. And some of them liked it and some of them didn't. All right, next one. X squared plus 3x minus 18. So we need numbers that multiply to 18. Numbers that multiply to 18 are 1 and 18, 2 and 9, 3 and 6. But oh no, none of those multiply to negative 18. However, do I make something multiply to be a negative? I make one of them negative, and because I want to add to be positive, I make the little one negative. So then negative 3 and positive 6 add together to be positive 3. 6 minus 3 is 3. So it's going to be x minus 3 times x plus 6. Something that's important for us to understand now as people who are like past Algebra 2 and like not just tried to scrape by in Algebra 1, is what this means. And being able to check these really quick in your head. So if I wanted to check this, I would do x times x is x squared, and then I would do, I usually do the last one first, actually. I do negative 3 times 6 is negative 18, and then to do the middle term, I do x times 6, that's 6x, negative 3 times x is negative 3x, and double check, okay, yeah, 6x minus 3x will be positive 3x. Okay, next one, we need to multiply to 6 and add to 5. Numbers that multiply to 6 are just 1 and 6 and 2 and 3. Those add to 7 and 5. And I know I need them to be positive because I have to multiply to be a positive. How else can I multiply to be a positive? 2 negatives. I'm asking you all the like planted questions I ask my Algebra 1 kids, but it takes them like 30 minutes to figure it out. And you already know. Algebra 1 runs deep with me. That's all I do. Okay, so x minus 2 and x minus 3. Because then the negative times negative will multiply to be positive, but then it'll add to be negative. Okay, and then I just put a fourth one on there for good measure because since we had one negative where the little one was negative, I wanted to have one where the big one was negative. So numbers that multiply together to be 14 are just 1 and 14 and 2 and 7. But since we need to add to be negative, we're going to have to make our big guys be negative. So it'll be 2 minus 7 is negative 5. What's up? Yeah. Yeah. Where do you need to go? Okay. Okay. It's my sister. You can have it too. It's my sister. Okay. Oh, I tried to pause that, but it didn't pause. I'll cut it out. Okay. Hi. I'm back. Okay. Any questions about any of those four? Do we remember those? Yeah? Find two numbers that multiply the last, add to the middle. Okay. Here is the one last thing that we're going to do today. This all works fine and well if our leading coefficient is equal to 1. If our leading coefficient is not equal to 1, that's when poop hits the fan. I was gonna say shit, but then I just said shit. So okay, sorry, recording. Okay, that's when things hit the fan. So if your leading coefficient is not equal to 1, we are going to combine together leading coefficient being equal to 1 and factoring by grouping. This is called the AC method. I don't know what other people call it. That's just what I've always called it. I think that this is the most foolproof method to factoring. There are other methods. In fact, I don't remember learning AC method when I was a child. I don't remember what I learned, which tells me that it's not as good of a method because I forgot it, obviously. The AC method is what I think is the best way to factor a trinomial with a leading coefficient greater than 1. So what you do is we are going to multiply together AC. We're going to find two numbers that multiply to equal that. So now instead of just multiplying to equal C, you need to multiply to AC. You still need to add to B. So we still find those two numbers, but now instead of just multiplying to C, we have to multiply to A times C. And then from there, we're going to split our middle term. And factor by grouping. Okay, so it's an extra step at the beginning and then grouping, basically. So this is when people use the magic X actually more, because you actually have to figure out that number that goes in the top there. So I'm going to use the magic X. I'm going to put it down below, though, so I can leave my space up there to do my work. So in the top, we're going to put A times C. So that's going to be 8 times negative 3. So I'm going to put negative 24 up top. And then my bottom is my B, so that's just negative 10. And then from here, now we can fill that out. Numbers that multiply to negative 10 add to negative 24. What numbers multiply to be 24?
Negative 12 and 2.
12 and 2. You want it to be 4 and 6 because they add to 10, but then you can't make them both negative and so multiply to be negative. So 12 and 2 is correct. So 2 and 12, and we make the 12 negative. So it's going to be positive 2, negative 12. So that is this first step. Find two numbers that multiply to AC, add to B. Now we use those two numbers to manipulate our polynomial and rewrite it. All we're doing when we're rewriting it is splitting up this middle term. So 8x squared stays the same. And then we've got plus 2x minus 12x. And we still have minus 3. Okay. The reason why we're allowed to do that is we are just uncombining like terms. So we could just do 2x minus 12x, get back to negative 10x, it's still equivalent. So we are unsimplifying it to make it so that we can factor it by grouping. From there, factor by grouping. So out of 8x squared and 2x, we can pull out 2x. That leaves behind 8 divided by 2 is 4. Leaves behind 1x. And then 2x divided by x is 1. You have to put a 1 there, so you have something to like multiply it against when you if you were to distribute it back in to keep it equivalent. Negative 12x minus 3. You can divide those both by 3. Hint of the day, if when you're factoring by grouping, your third number here is negative, your second GCF you pull out is also going to be negative. So we're going to pull out a negative 3, because then that'll leave behind a positive 4x and a positive 1, which will match. So then our final answer here is 4x plus 1 and 2x minus 3. Questions, concerns, emotions, thoughts? It's really just 2. Because it's find the numbers that multiply to AC, add to B, and then factor by grouping. Do it enough and you'll, if you can remember that first step, then and you can remember how to group, it's just remembering to put it together. All right, last one. Let me know if you have questions. Also, announcements did come, so we can watch those after we're done with this, and then you can get started working on your assignment. Last one is 6x squared plus 19x minus 7. So I'm going to make that magic x down here. 6 times negative 7 is negative 42. And then I need to add to be 19. Numbers that multiply together to be negative 42 and are 19 apart from each other are 21 and 2. So we'll do 2 and 21. Which one should I make negative to multiply to a negative? 2. So if you need to add to be positive, you want to leave the bigger one positive. If you need to add to be negative, make the bigger one negative. So I just think about it as make the more powerful one what you want it to be. Cool. So from there, we'll split up our middle term. 6x squared stays the same. And then all we're doing is uncombining like terms. We're doing it on purpose. So it's going to be minus 2x plus 21x from our magic x down below. And we've got our minus 7. Okay. Factoring that by grouping, my first group, 6x squared and 2x. Just like in the last one, I can divide out a 2x. That is a complete coincidence. 6 divided by 2 is 3. Leaves behind an x. And then negative 2x divided by 2x leaves behind a negative 1. (21) and 7. We can divide a 7 out of both of those. Leaves behind 3x and negative 1 as well. Okay. GCFs that match are 3x minus 1. And our other two guys are 2x plus 7. Awesome. Any questions right now about all of this review of factoring? Okay. Let me stop this video. Bye, video.
Bye, video.